The views expressed in this podcast or on www.constellationspodcast.com do not officially represent the views of the U.S. military or the United States government. The appearance of U.S. Department of Defense, DoD visual information does not imply or constitute DoD endorsement.
Welcome to Constellations, the podcast from Kratos, where industry leaders share their thoughts and experience on the future of space business, policy, and opportunity. If you like Constellations, please support us by giving a rating and review on iTunes. And don't forget to share this podcast online to help our community grow.
Welcome to Constellations, the podcast from Kratos. My name is John Gilroy, and I'll be your moderator. We are here in lovely downtown Logan, Utah, at the SmallSat Conference. Our guest is Dr. Frank Turner, Technical Director of the Space Development Agency. In the world of space and satellite, the SDA is small but powerful. The way I understand it, Frank, is that what you folks do is you quickly deliver needed space-based capabilities to the warfighter to support terrestrial missions. The way I understand it from your website, it looks like you're going to be delivering an MVP, a minimal viable product, every 2 years by employing spiral development methods. So how do I do? Is that close?
That is absolutely right on the money. You're doing great.
So how do you differ from the other federal agencies?
I think the real difference in SDA is the model that we use and the way that we approach acquisition. We believe that schedule is king. Schedule is all important, and we will hold schedule and we will trade capability. Because when you do things on 2-year centers, so that we're putting out a new tranche of satellites, a new capability every 2 years, then the warfighter only has to wait for that next level of capability for 24 months. And it's better to give them an 80% solution on time that they can depend on than wait for that next 10% or 5% or that next really exquisite capability that will be the greatest thing, but it still takes you 5 years, and for 5 years they don't have anything to work with.
So I guess from 40,000 feet up, your customer is the warfighter.
Our customer is absolutely the warfighter.
And so what you're trying to do is solve problems for the warfighter. So what is the biggest problem your agency is trying to solve for a typical garden variety warfighter?
As we move into joint all-domain operations as a concept that the Department of Defense wants to employ to enable sensor-to-shooter, to enable the data that needs to be at the tactical edge to get there on tactically relevant timelines, then what we have to do is we have to lower the latency of that data by moving it as fast as we possibly can. And we also have to make sure that there aren't barriers to go from data wherever it's created to wherever it's needed. And that's the key thing that we're working on for the warfighter, getting the latency of that data down and enabling that transmission, that transport from point A to point B so that it's enabling decision-making at the absolute tactical edge by virtue of the data that they have available to use.
Feds at the edge, it sounds like, huh? That's what it is. I've had many conversations with software developers, and I learned the term agile software development and lean software development and all this kind of stuff. At your website, you talk about spiral development. And so maybe you can differentiate that for the software developers listening here.
The whole idea behind spiral development is that you want to put out a capability and you want to do it on time and you want to have something that the warfighter can count on. And I'll give you a couple of examples. Our Tranche 0 satellites, which are going to launch in 7 weeks at the end of September, is going to be the first set of satellites where we're going to actually put Link 16 in space. Link 16 is a very prolific tactical data link that the military uses to fight wars. So that's the way they communicate. That's the way they move data. There are 35,000 Link 16 terminals out there that everybody uses, not just the U.S., but our allies and partners. So we're going to demonstrate that we can move data over Link 16 with T0. Well, the next spiral, our Tranche 1 capability, which will begin launching in September of 2024, will take that Link 16 capability that we're going to demonstrate starting this year, and it will turn it into a global access capability that the warfighter from any point on the globe can use, and will be able to support one regional conflict. We'll have regional persistence in our Tranche 1. Then in Tranche 2, we'll fill out that capability with a global persistence so that we can do multiple regional conflicts if necessary. So in T0, we do the demonstration, we get it up there the first time. In T1, we make it globally accessed but regionally useful. And in T2, we make it globally accessed and globally useful. So it's that constant next capability on 2-year centers the warfighter can depend on, and that gives us those spirals as they come out.
The software folks talk about continuous development, but in a warfighting environment, you don't have a choice. I mean, it has to be continuous and all the time, doesn't it?
Yes, it absolutely does. And we, for the software that we're building for the command and control software, for the mission integration, for the network maintenance, and all of those things that we're doing exactly the same agile continuous development as everyone else is doing in the software world. And we're also extending it, if you will, to a hardware model where we're constantly bringing out those spirals.
And what is interesting is that you're applying it to large mission-critical projects, where a lot of people would apply maybe an agile software development, something small, but this is serious business. This is military serious application, and so it's kind of difficult to accomplish some of those goals, I would think.
It is, but one of the things that we really depend on is we depend on our industry partners to bring us capabilities that we can actually do, we can actually deploy. One of the things that we pride ourselves on is we're looking for technology readiness level TRL 6 or better by CDR so that we know that technology is ready to go to space. It may not be a 9 because it may not have been to space. Link 16 is a great example, but we know it's ready to go to space, and we feel very comfortable that we can actually get it up there and it will accomplish the mission it's intended to do.
I was at your website and I was reading, there's a lot of good stuff there. What it looks like is you are working on something called a transport layer that will be comprised of a network of small satellites in LEO. Maybe at the same time, you're working on something called a tracking layer. So is there a relationship between these two, or how do they help the warfighter, your customer?
So the transport layer has been called by the Joint Staff the backbone of JADC2, Joint All-Domain Command and Control. So the transport layer is that mesh network in space that will enable low latency, resilient movement of data for the warfighter from point A to point B on a global scale. So we're building a mesh network in space that's optically enabled. We're putting optical intersatellite links on our space vehicles so that that data can move at light speed. The tracking layer is actually going after a very specific warfighter problem, which is next generation advanced missiles. So we're going to contribute to the hypersonic fight. We're going to contribute to warning, tracking, and defeat of the advanced missiles that our adversaries are developing and deploying that will change the 21st century battlefield completely. So we're contributing to that. The data from the tracking layer will actually move over the transport layer so that we reduce the latency in that data as well, and we get that information into the fight as fast as possible. So the transport layer, think of that as the backbone, as the key thing that holds it all together, kind of the linchpin. The tracking layer is a specific capability going after missiles, and then we've got another couple of capabilities that go along with it, but it's all enabled by the transport layer.
You know, Frank, it may surprise you, but people from all over the world listen to this podcast, so you're going to be famous all over the world soon. I think earlier today we had a guy from Poland walk up here, and he said, yeah, I listen just to keep up with what's going on. And so what happens is when we use vocabulary words, I try to make them accessible to everyone.
Right.
And so earlier you used the word tranche, T-R-A-N-C-H-E. And so if you're listening in Poland or Japan or whatever, it just means a portion or a section or a group, right? I mean, that's what a tranche is.
What we call our tranches, they are our spirals.
Okay.
So it's a capability. To be honest, the term tranche was coined by SDA before I got there. I'm not sure exactly where it came from. But you could call it something besides a tranche if you really want to, but just think of that as one of our spiral capabilities.
Within spiral development. Now it all makes sense. That's great. That's great. Let's talk about tranches, as you say. You know, it looks like the SDA will be introducing satellites in the constellation every 2 years in tranches. At some point, it's a very sensitive point for me, the first satellites launched will be technologically old. So what's the plan to deal with these old satellites?
Well, We're only designing satellites for a 5-year lifespan anyway, and we're making sure that satellites have a capability to deorbit. We are good stewards of the orbital realm. We're not going to leave trash up there. We're not going to leave junk up there. The ability to deorbit those satellites and get them out of the planes that we're operating in is very important to us. So if we assume that at the end of 5 years and they're up there, they're going to deorbit anyway. The other thing is, if we reach a point where we need to, we will deorbit a functional satellite because it's time. It's outlived its usefulness. There's a new tranche coming. There's a new capability coming, and we'll literally deorbit it. The idea here is we want to transition space to think of it as an automotive model. Think of it as an electronics model. When your iPhone gets old, you just throw it away or you trade it in or something like that, even if it still works. And that's exactly what we want to bring to space. We're lowering the price points, and when they're no longer useful, we'll get rid of them. So
kind of an interesting question about this transition. So will all future tranches have reconstitution aspects to them? In other words, maybe Tranche 2 will include acquiring more Tranche 1 satellites as spares, so they work together in different segments, huh?
For the most part, no. As you do something like an SDA construct, then the idea of replenishment, reconstitution, it literally becomes something that you have to think of in a different way. If one of the things that we're doing with each tranche is we're increasing capability a little bit, affordably, and that we can get on a very defined schedule, then we actually don't have the ability to do a lot of replenishment and reconstitution because we're already building and launching new satellites about as fast as we can.
Wow. In my world of cloud computing, everyone talks about vendor lock-in. It's like, it's a tough word. So let's take it over to your area here. So how do you create or support a competitive marketplace where you can avoid vendor lock-in or proprietary systems taking over?
A number of ways, actually, and I'll quote our director, Dr. Derek Turnier, #capitalism. SDA does not believe in incumbents. SDA does not believe that just because a company or companies is providing Tranche 0 satellites, that they should provide Tranche 1 satellites, Tranche 2 satellites, Tranche anything satellites. Everybody has to compete every single time, and they have to compete on as much as we can make it a completely level playing field at that point. So, as an example, we have 4 primes in Tranche 0. We added a couple of different companies in Tranche 1 as we're building out what Tranche 1 is going to look like, and we're up to 3, 4, 6. We'll probably end up with a total of maybe 8 or 9 prime contractors building Tranche 1 or affiliated sets of space vehicles. But the goal always is it's a level playing field. Each acquisition is independent, and folks bid if they want to. But what we're trying to do is send enough demand signal and make sure that people understand the schedule so that if a company wants to invest in being able to win a contract from SDA, it's up to them.
Well, sitting on the floor here at the Small Sat Show, there's hundreds of companies that want to hear that, aren't they? They really want to hear that and say it again. That's good news for people sitting behind us, in front of us, all over the place. Frank, thousands of people from all over the world have listened to this podcast. Go to Google and type in Constellations Podcast to get to our show notes page here. You can get transcripts for all 100-plus interviews. Also, you can sign up for free email notifications for future episodes. So let's look up in space a little bit now. Take our eyes off of Utah and look up in space. It seems that the government wants commercial companies to send data directly to their constellations to SDA satellites. Instead of going vertically, they want to go horizontally. So why is that, and why makes it so difficult?
Just like the government has multiple networks for its data, there's the basic completely open internet, and many a government person uses the completely open internet for all kinds of different things. And then you get to the level where the government closes the internet just a little bit, but the information is still unclassified. And then you get to SIPR, the secret internet, if you will, and then finally up to a full-blown top-secret level with J-Wings. So the government has multiple networks terrestrially to enable the data that it needs to send depending on the security requirements of that data, depending on the latency the data can stand, depending on the importance of the data. The space environment will be identically the same. And let's take some of the emerging multi-satellite constellations. There's plenty of information the government can and should use those constellations to send. There will be opportunities for those companies to have contracts with the government, to move government data, to make lots of money. That's exactly what should happen. Again, hashtag capitalism. Then, by the same token, there will be information that the government needs. It needs the security. It needs the dependence on that set of satellites, and that's what SDA is doing. We're putting that infrastructure in place that will be owned by the warfighter, used by the warfighter, and when the time comes, and if we actually have to go to war and use a spaceborne layer to prosecute that war, that's what SDA is providing.
And that is, again, music to the ears of all the people here at this conference. This is the right place, the right time, Frank. You're the right place here. Let's switch topics here. Let's talk a little bit about optical intersatellite links, we just mentioned. And I think your agency is used to create these mesh networks. Have you changed strategies to found a different way, maybe to transport layer more quickly around this data? Anything new?
Well, I spent time over my career at AFRL, at NRL, and at DARPA. I apparently cannot keep a job. But I was at all of those places, and I know beyond a shadow of a doubt that they're working on something faster than the speed of light, but I don't think we've found it. So we're actually all in on optical intersatellite links. And the Tranche 1 satellites, as an example, will have 4 optical intersatellite links on them to make sure that we can go cross-plane and we can go in-plane so that we can build that mesh network in space. And as we move into Tranche 2, Tranche 3, our goal is that we reach a point where we can actually put up to 6, potentially, so that not only can we go cross-plane and in-plane, we can go up so that we can connect to satellites in MEO, medium Earth orbit, GEO, geostationary Earth orbit, and we can actually go to the ground all the time from each vehicle. So we are all in optically. We've published a standard. It's on our website. It's completely open. People can go look at it. The goal being that we are trying to help the DoD and industry understand this is where the warfighter's going, and we're going to make it such that the warfighter can communicate optically globally.
You know, when you said the speed of light, I was reflecting on this guy named Vint Cerf. We interviewed him a couple years ago. He's working on deep space internet. And I said, well, Vint, what is your biggest challenge? And he said, well, my biggest challenge is the speed of light.
That's exactly right.
I said, that's a little over my pay grade. He's very well known in many communities. Your agency, the SDA, recently issued a solicitation for the National Defense Space Architecture Experimental Testbed Satellites. So what are they doing differently?
One of the things about SDA is we have been labeled by the Department of Defense as the constructive disruptor in acquisition. We have a completely different model. We're doing things differently. We're doing things on different timelines, at different speeds. You name it. We're just doing different stuff. Well, one of the ideas behind disruptive technology is that it's always a good idea. So SDA, we've gone through now a total of, I think we're up to 8 or 9 acquisitions. We've done them all the same. They look a lot alike. The proposals look a lot alike. But by the same token, what we need to do is we need to think about, well, how do we, SDA, disrupt our own model? What is it that we can do to do something different in space? So the idea behind NEXT, the NDSA experimental testbed, is that we're actually looking for ways and means to provide new capabilities to a proliferated low Earth orbit, proliferated LEO set of constellations, and we kind of want to do a try before you buy, if you will. So what we're doing is we're buying space vehicle buses off the ends of assembly lines, And we're then taking those buses, we're going out to government mission partners, we're looking for payloads, and then we're going to launch those satellites and operate them with our mission partners, looking for those next capabilities that we would then proliferate in Tranche 2, Tranche 3, Tranche 4, so that we have already identified the next set of capabilities the warfighter needs.
Well, here we are in Utah here, and I see people in uniform floating around. I see a lot of students, and I think there's a lot of startup companies, too, which means a lot of new ideas. And you have been quoted as saying that the SDA is open to new ideas and want to have a conversation about those ideas. So where can someone, maybe at the conference or someone listening to this, where can they go to discuss what they have to offer you?
Well, one of the things, there's a number of ways. So let me start by saying that you can always send an email to osd.sda.outreach@mail.mil, but that's a blind email box. It comes in, we take a look at it, and we'll respond. And I know for most folks, they say, well, if I send an email, nothing's going to happen. I promise you something will happen, but I can understand where that's not a great thing to do. If you happen to know the folks at SDA, people at SDA are very, very willing to talk to you. So if you know the right person to talk to, by all means, send them an email, give them a call. We're looking for those capabilities. If you don't know the right person to talk to and you don't want to just send an email, I've said before in open forums, and I'll say again, I'm always willing to talk to people. Just give me a call, send me an email. I spent too many years in industry where the government wouldn't talk to me. And I swore when I came back into the government, I would not be that person. I wouldn't be the one that just because I'm a government person in a government organization, I would say, well, I don't have to talk to industry anymore. That's not the idea. It's a partnership. We can't be successful unless industry's successful. I'll always talk to folks.
Well, Frank, thanks for giving our listeners a greater understanding of the complex software development projects to assist the warfighter. I'd like to thank our guest, Dr. Frank Turner, the Technical Director for the Space Development Agency.
Thanks for listening to Constellations, the podcast from Kratos. If you like this interview, please subscribe, tell a friend, and give us a review.